Okay, next we are going to see what is a scalar product. So as you can see from here, we have 4 different parts for scalar product, which is for this video we are going to cover these 3 parts here, which is we are going to see what is the definition of scalar product, which is sometimes called as a dot product, and we are going to see the properties and how to find the angle between 2 vectors. So let's see, this is the scalar product, and here we have the definition of a scalar product. So we have A dot B equals to, do you remember what is this? The modulus A? A magnitude, okay? So magnitude A times by magnitude B times by cos theta, okay? For vectors, everything has to be in degree, okay? If before this, your trapezoidal rule, your trapezoidal rule lah basically kan, dengan Newton-Raphson, you have to put in radian. Okay, because whenever you see trigonometry, you have to focus on the mode of your calculator, either degree or radian. But for vectors, everything must be in degree. Okay, so if you see vector questions, just change your mode into degree. Okay, so here we have cos theta. What does it mean by cos theta? Theta here is basically the angle between vector A and vector B. As you can see from here, this is vector A, this is vector B. So this is theta, angle between vector A and B. Okay, so if A dot B greater than 0, this is A dot B greater than 0. If you get A dot B equals to 0, what can you see from here? The vector is perpendicular. Okay, the vector of A is perpendicular to B. That means your theta is equals to 90 degree. Okay, if A dot B is less than 0, or if you can see that theta, your theta is greater than 90 degree, your theta is greater than 90 degree, that means A dot B is less than 0. As for this one, if your theta is less than 90 degree, A dot B is greater than 0. Okay, so that is what's about the angle between 2 vectors. Okay, so here the definition of the scalar product. We have how to find A dot B. So just basically we use this formula, A1 B1 plus A2 B2 plus A3 B3, which is you are going to get a value. Okay, you are going to end up with some value here. So let's just go through to example 5 here. We have evaluate A dot B. Okay, if A equals to 3i minus 7k, B equals to negative 2j plus 3k, and the angle between A and B is 139.9. So let's just use the formula, okay, which is the formula is A dot B is equals to vector magnitude A magnitude B cos theta. Okay, so that is the formula. So we have to find magnitude first. Let's find the magnitude of A because we have the vector here. So magnitude of A is equals to square root 3 square plus negative 7 square. Okay, which is we have square root 58. So let's find magnitude of B. So square root negative 2 square plus 3 square, which is we have 4 plus 9 equals to square root of 13. So to find A dot B, just simply use this formula here. We have A dot B equals to square root 58 multiplied by square root 13 cos 139.9 degree. Okay, make sure your calculator in degree, and we have negative 21 here. Okay, so that is one way to find dot product, okay, A dot B, by using this formula here. Okay, so let's see the second method to find dot product, which is by using this formula here. We are going to end up with a number. Okay, scalar product, nama pun scalar, kamu akan dapat a value. So here we have A dot A. So this is our vector A. So we have 2i plus 3j minus 5k dot 2a, 2i plus 3j minus 5k. So simply just this one we have to expand. This one you can expand. So you should get 2i plus 3j minus 5k dot 4i plus 6j minus 10k. So how are we going to do a dot product? By using this formula here, a1 b1. So just simply 2 times 4. Okay, 2 times 4, which is we get 8. Okay, see here, I dot I. What did you get for I dot I here? You get equals to 1. Okay, that is how vector product works. So we are going to see this more on in the properties later. So 2i dot 2i multiply by 4i, you get a 8 times I dot I is 1, so 8. So here is 3 times by 6, we have 18 minus 5 minus 10 times minus 10, we have plus 50, which is we get equals to 76. Okay, this one, the same thing works here. You can find it by yourself, which is you're going to get negative 60. Okay, so I'm going to give the answer for this one. Make sure to find it by yourself. Okay, let me show you one more ways to do vectors. Okay, which is we know we can use this type here, ijk, and we can always do like this. Okay, 3i minus 2, 3j minus 2k, the same thing as I. You don't have I here, so that means we have 0, 3, negative 2, dot with 1 to negative 7. Okay, how are we going to do the dot product? 0 times by 1, we get 0. 3 times 2, we get 6, plus 6, 0 plus 6. And negative 2 times negative 7, we have plus 14, equals to 20. Okay, so if you want to do other way to write your vector product, make sure you write it in the right way. Okay, either this one here or column matrix, or this one you have to put ijk with the wave, okay, below the letter. So let's see the properties of scalar product. Okay, as you can see from the first one, a dot a is equals to modulus a square, or what can you see from here? This is magnitude square. Okay, magnitude square. This one you have to remember. Many of you guys forget about these first properties. Okay, so make sure a dot b is equals to modulus a square, or magnitude square. So a dot b is equals to b dot a, the same thing. And here you can just look at by yourself. The most important properties here is the sixth one here, the number 6. A dot b is equals to modulus a modulus b if and only if a parallel to b. Okay, what does it mean by that? So if this one, okay, let me write here number 6. Okay, if we have a vector which is, this is vector a and this is also vector b. Okay, as you can see, if it is parallel, or let me write one more vector here. We have vector a, and we also have vector b. Okay, which is both of these vectors are parallel. That means if it is parallel, your theta equals to 0. Okay, let's see, if we use the formula of dot product or scalar product, we have a dot b equals to magnitude a magnitude b cos theta. So what is your theta here? Which is 0. So cos 0 is equals to 1. So you end up with magnitude a magnitude b. So that is why we have the properties. If a parallel to b, a dot b is equals to magnitude a magnitude b. Okay, if it goes in the opposite direction, just put the negative. Okay, we already see this in the types of vectors. Okay, here we have the number 7 properties. Okay, this is very important. Number 7 here, which is a dot b is equals to 0. Okay, here we have a dot b is equals to 0 if a is perpendicular to b. Okay, why like that? As you can see here, if we have the vector, this is, let's say, This is your vector A, and this is your vector B. Obviously, this is perpendicular, 90 degree. Okay, if you have 90 degree, that means your theta here is 90 degree. Okay, by using the same definition here, we have A dot B equals to modulus A, or magnitude of A, magnitude B, cos, what is your theta here? 90 degree. Okay, cos 90 degree, you get 0. That means all the thing here is 0. Okay, so what you have to remember from the properties here is, if A is perpendicular to B, A dot B is equals to 0. Okay, so for number 8, I already explained to you. I dot I, you get 1. J dot J, you get 1. K dot K, you get 1. Okay, so the same thing work here if you dot product between the two different vectors, we'll get 0. Okay, so now let's see example 8. Simplify A minus B dot A plus B. Okay, so let's just do this one here. We are going to expand first, which is you get, let me zoom in a little bit. Okay, we are going to expand, so you should get A dot A plus A dot B minus B dot A minus B dot B. Right, so A dot A. So from the first properties, remember, from the first properties, A dot A is equals to magnitude A square. So this one here is magnitude A square. A dot B minus B dot A. Is B dot A the same thing as A dot A? A dot B. Properties number 2, yes, it is. So basically, A dot B is equals to B dot A. So this one here will be 0. So B dot B is equals to minus magnitude B square. So that's it. Okay, so we have it here. So just remember, this one here is A dot A is equals to magnitude A square. Very important properties. So let's see the next one here. We have A plus B dot C, which is, if we expand, we have A dot C plus B dot C minus A dot B. Remember to put big bracket here, plus C dot B. Okay, if we simplify this, as you can see from here, B dot C and C dot B is basically the same thing. Okay, so we can cancel out this, minus minus, you'll get 0, and we end up with A dot C minus A dot B, which also can be written as A dot C minus B. Okay, from properties number 3. Okay, so let's see the next example, example 9. Given that A, B, find T if A is perpendicular to B. As you can see from here, we have a constant T in both of our vectors. So we have to find what is T. But the keyword here is perpendicular. A is perpendicular to B. So what do you know from properties of scalar product? We know that if A is perpendicular to B, that means A dot B equals to 0. Very, very, very important properties. Okay, A perpendicular to B, A dot B equals to 0. So here we have A dot B equals to, our A here is, okay, I'm going to use column matrix here, 3T negative 2 dot with 1 minus T negative 3 4. Okay, so let's solve this. We have 3 1 minus T minus 3T minus 8. Okay, so that's it, A dot B. So we know that since A is perpendicular to B, so we know that A dot B is equals to 0. So A dot B is equals to 0. So we have 3 minus 3t minus 3t minus 8 is equals to 0. So here we have negative 60 equals to 8 minus 3, we have 5. T is equals to negative 5 over 6. Okay, so that is how you use the properties. Okay, very, very important properties. Always asked in the question. The question normally doesn't say by using these properties, by using these properties. You have to know it by yourself. Okay, so please take note on all of these properties of scalar product. Okay, so let's see the next part, the angle between two vectors. So we already know that A is a vector, B is a vector, so we are going to find the angle between two vectors, which is the theta here. So we know the formula, A dot B is equals to magnitude of A, magnitude of B, cos theta. Okay, which is to find the angle, obviously the angle, we are going to find the theta. So let's just rearrange that. We have cos theta equals to vector A dot vector B over by the magnitude. Okay, magnitude of A, magnitude of B. Okay, so to find theta, basically just inverse cos all of this thing here. Okay, remember angle between two vectors, you need two vectors, so we have vector A, vector B, so the formula is A dot B over magnitude A, magnitude B. So this is what you are going to memorize, very important. And remember, as I said before, this one has to be in degree. Your mode calculator mesti kena dalam degree. Okay, so let's see. Let me just draw one more time here. We have, this is vector A, this is vector B, so this is actually your theta. That is what we are going to find. Let's see example 10. If magnitude A equals to 4, magnitude B equals to 3, and A dot B equals to 7, find the angle between A and B. Very basic question, straightforward, just use the formula. Cos theta equals to A dot B over magnitude A, magnitude B. So we are going to substitute everything. We have A dot B equals to 7, we have magnitude A equals to 4, we have magnitude B equals to 3. So here we have 7 over 12, we have 7 over 12 obviously. So here we have, okay, 7 over 12, let me write that by, okay, so what we're going to find is basically just theta, so inverse cos 7 over 12, you should get 54.31. Okay, so one more time, remember in degree. Okay, very basic, just use the formula to find the angle between two vectors. So let's see one more example here. Example 11. A, B and C are 3 points such that AB, direction vector of AB, is equals to 3i plus j, BC is 2i plus 3j. Find the angle ABC. So what does this question want? So let's just draw a triangle here with A, B and C. Okay, what do we have? We have AB and we also have BC. Okay, the question asks us to find the angle ABC. So which one? ABC, that means the question want to find the angle here. Okay, at B, ABC. So here what we are going to find? This is your theta. Okay, always in the center. That is what you're going to find. So what do we have? We have AB and we also have BC. So from here, angle between, which we want to find, angle between theta is angle between BA and BC. Okay, you can see that this is the angle that we want. Okay, because the B is in the center, so theta is basically the angle between BA and BC. That is the direction vector that you have to find. Okay, the blue one, BA and BC. So you already have BC from here. This one you already have BC. So we don't have BA, but we do have AB. So what do you know from this thing here? You have AB, but you want to find BA. the negative vector. Okay, if it goes in the opposite direction, you have to put the negative. So that means we want to find BA, just put negative AB. Okay, so here we have negative 3I minus J. Okay, let me rearrange this first. Okay, so we have BA. So find the angle ABC. So the same thing, just use the formula cos theta equals to A dot B over magnitude A, magnitude B. So in this case here, we are going to find BA dot BC. Okay, to find the theta is the angle between BA and BC. So the formula is cos theta is equals to BA and BC. So that means you should have the vector of BA dot with BC over magnitude of BA, magnitude of BC. So a little bit different. Instead of we have the vectors, here we have the direction vectors. So just substitute everything. We have BA which is negative 3I minus J, negative 3I minus J, and we have dot BC, which is BC we have 2I plus 3J, okay, over by the magnitude. So magnitude of BA we have square root negative 3 square plus negative 1 square, multiply by magnitude of BC, which is 2 square plus 3 square. So up the numerator, we should get negative 6 minus 3. Okay, here we should have square root 9 plus 1, which is square root 10. Here we have square root 13. Okay, cos theta, cos theta. And here you're going to get the answer. Theta is equals to inverse cos negative 9 over square root 10 square root 13, which is the final answer is 142.13. Okay, that's going to be the final answer. That is the angle for AB here. Okay, you might notice something different here. Is this AB? This 142.13, this angle shouldn't be less than 90 degree. Okay, sometimes the question might ask you find the acute angle, so you have to minus by 90. Okay, if you get this final answer, then it's fine, just leave it like that. Okay, so let's see the last example here, example 12. We have the angle between vectors A and B is cos inverse 1 over 84. Find lambda. So this question is a little bit complicated, so that's okay. Let's do that. Okay, so what do we have here? We have A, B, and we have the angle basically. So just put the formula. We have theta is equals to inverse cos A dot B over magnitude A, magnitude B. Okay, so theta, we do have the theta, which is inverse cos 1 over square root 84. And here we have equals to inverse cos A dot B over magnitude A, magnitude B. So A is I plus lambda J. Instead of that, let's just put in this bracket here. 1 lambda 2 dot B, we have 2 3 1. Okay, over by the magnitude, which is we have 1 square lambda square 2 square. Magnitude of B is 2 square plus 3 square plus 1 square. Okay, lambat sikit, make sure you calculate sama-sama dengan saya. So here we have cos inverse, cos inverse. Obviously, if you move cos to the other side, we can cancel out each other. So we are going to left with this one here and this one here. So we have 1 over square root 84 equals to vector 1 lambda 2 dot vector 2 3 1. If you want to write 1 I plus lambda j plus 2k, 2i plus 3j plus k also can. Okay, no problem. over, here we have 1 plus 4, we have 4 plus lambda square. Is it? Yes, 4 plus lambda square. No, 4 plus 1 is 5, sorry, 5 plus lambda square. And here we have 4 plus 9, 4 plus 9 plus 1, we have 14. Okay, so that's what we have here. Okay, now we are going to rearrange everything. We are going to move this to the other side, 1 over square root 84 to the other side. This one to here, this one to here. So we have square root. Move everything together. 14, 5 plus lambda square equals to, let's solve this dot product here. We should have 2 plus 3 lambda plus 2. Okay, square root 84. Okay, so here we should get 4 plus 3 lambda square root 84, and here you should get 14 times 5. We have 70 plus 14 lambda square. Right. Okay. Semua orang okay? Make sure jangan tertidur pula. Here square root, move to the other side. We have 70 plus 14 lambda square, which is everything on the right side is gonna be square. 4 plus 3 lambda square root 84 squared. Okay, so we are going to expand on the right hand side, which is we have 4 plus 3 lambda square, which is 16, plus 24 lambda plus 9 lambda square, everything multiplied by 84, because we have square root 84 square, that's gonna be 84. 70 plus 14 lambda square. Okay, rearrange everything. You should get, lastly, I'm not going to do this, you're going to do it by yourself. We are going to have 53 lambda square plus 144 lambda plus 91 equals to 0. Okay, we end up with a quadratic equation. So what do we have from here? We are going to have, okay, let's just input everything inside your calculator. 53, 144, 91. So here we have negative 1, lambda plus 1, and also we have 53 lambda plus 91 equals to 0, which is we have our lambda equals to negative 1, lambda equals to negative 91 over 53. Okay, are you guys okay? Still remember what are we going to find here? We are going to find lambda. Okay, so we use the formula of the angle between two vectors. Since we have the lambda, so we have a constant. Okay, we just rearrange basically from this, from here to here, just rearrange until we get quadratic. And here we have two value for our lambda. We have lambda equals to negative 1 and lambda equals to negative 91 over 53. So we have to recheck our value of lambda. Why? As you can see, this one here, we have theta equals to, let's just put in our calculator, inverse cos of 1 over square root 84 is equals to 83.73. 83.73. Okay, which is less than 90 degrees. So this is your angle. Okay, this is your theta. This is, let's say, this is direction vector of AB. This is direction vector B. Okay, let's go to the first slide here. We know that if our theta is less than 90 degree, your A dot B has to be greater than 0. Okay, because our magnitude A times magnitude B is greater than 0. So from here, we know that A dot B greater than 0. So you know that this one here, the product of A dot B, supposed to be greater than 0. So we are going to check our value of A dot B by using this value of lambda and also this value of lambda. So recheck. Okay, when lambda equals to negative 1. Okay, what is the value of A dot B? So from here, from where your A dot B, as you can see, this is your A dot B. Okay, this is A dot B, so this is your A dot B here. So the product of these two vector, we get 2 plus 3 lambda plus 2, which is we get 4 plus 3 lambda. So this is actually your A dot B. So we are going to substitute lambda equals to -1 into that. So here we have 4 plus 3 times -1. So here we have equals to 1, which is greater than 0, okay, which is what we want to find. So let's see when lambda equals to -91/53. So your dot product here is equals to 4 plus 3 -91/53, which is here we get, what's the answer here? -61/53. As you can see, this is less than 0. Okay, so we can conclude that since here we have this one here, inverse cos 1 over square root 84, and this one here, we know that our A dot B is greater than 0. Therefore, your lambda is equals to 1. We can conclude that our lambda is equals to -1. Okay, because for lambda equals to -1, we get the dot product A dot B greater than 0. Okay, so that is example 12. A little bit complicated, but it's okay. Okay, we can deal with this. So let's go to the last example here. Example 13. Find the interior angles. Whenever the question said find the interior angles, that means every angle in the triangle you have to find. Okay, find the interior angles of ABC. So let's say here we have the triangle ABC. Let's label that theta. Let's label that as alpha, and let's label that as, let's just use alpha, beta, and gamma. Here alpha, this is beta, and this is gamma. Okay, so what you have to find is every angle inside your triangle here. So I'm just going to show you for one angle, which is, let's do alpha here. So you want to find this angle, which is BAC. Okay, that is what we are going to find, BAC, which is let as alpha. Okay, so the formula has to be this direction vector AB, AC. Okay, from the angle that you want to find from this point here, mesti kena pergi ke sini, mesti kena pergi ke sini. Okay, you have to find this direction vector, you have to find this direction vector from the angle, from the point that you want to find the angle. Let's say kalau kamu nak cari beta, you have to find this direction vector BA, BC. Okay, let's say if you want to find gamma here, has to spread like this. You have to find CA, you have to find CB. So in our case here, we want to find this angle here, alpha. So we have to go here, AB, AC. So that's the formula. Cos theta equals to AB, AC. So that means we have direction vector of AB dot direction vector of AC over the magnitude of AB, the magnitude of BC. Sorry, AC. Okay, so tak kisah terbalik pun boleh. AC dot AB pun boleh juga. Okay, we know that A dot B is equals to B dot A, so it doesn't matter. So here we have AB. Do we have AB and AC? As you can see from here, we have point A, point B, point C. Remember, this is the position vector. This is your OA, this is your OB, this is your OC. So what we have to find first is we have to find AB and AC first. So how are we going to find AB? Remember, start with O back minus O front. Okay, so the back is B, OB minus OA. Okay, so OB is this one here, -203. I'm going to use column matrix here, -203. OA is 135. Okay, so here we get the answer. -2, -2, we have -3, -5, -2. So that is our AB. Let's find AC. Okay, so to find the direction vector, start with O, O back minus O front. So OC minus OA. So the OC is 3, 1, negative 2. 3, 1, negative 2. And here is 1, 3, 5. So here we have 2, negative 2, negative 7. Okay, so we have the direction vector of A, B, and AC. What you have to do is just substitute into the formula that we have here. So AB is negative 3, negative 5, negative 2, dot with AC, 2, negative 2, negative 7, over by the magnitude. By this time, you should know how to find the magnitude, okay? So negative 3 square plus negative 5 square plus negative 2 square. And here we have 2 square plus negative 2 square plus 7, negative 7 squared. Okay, so the dot product of these two direction vector, we should get negative 6 plus 10 plus 14. Is that right? Wait, let me check one more time. This one here, why is it negative 5? 0 minus 3. Here you should get negative 3. Okay, minta maaf. Here should get negative 3. Is that correct? It is. Okay, so let's change here. It should be negative 3. And here should be plus 6. Okay, so we have negative 6 plus 6 plus 14 over square root 22 square root 57. Here is cos theta. So to find theta, just simply inverse cos everything, which is the final answer should get us. So here we have 14, inverse 14 over square root 22 square root 57. And the final answer, we should have 66.71. Okay, let's change this one. We are finding alpha. Okay, so that is the value for your alpha. Remember, vectors degree. Okay, must be in degree. Please take note this. Make sure your calculator is in degree mode. Okay, so that is only one thing. We only find the value of alpha here. So the question asks for interior angle. That means the question wants to find beta here and alpha here. Sorry, gamma here. So what we have to do is exactly the same thing, but only apply to a different direction. Okay, so if you want to find beta here, you have to find BA and BC. So you have to find BA dot BC, vector product BA, magnitude BC. Okay, so I'm going to give the final answer, which is beta is equals to 76.2 and the value of gamma is equals to 37.1. Okay, please make sure to do this question completely and get the final answer for every interior angle. Okay, that's all. I'm going to continue into the next video. Kalau tak, sampai besok video ni.